Hello everyone, welcome to my channel. My name's Jasmine, and this here would be the third addition to TryHackMe's pre-security learning path. It's called How the Web Works, and I just wanted to let you know I'm only practicing my public speaking. So if you want a better presentation, please go on their actual website, especially if you want the answers and you want the walkthroughs of the simulations and labs. Just go on their YouTube channel for that, because I will not be doing that in this presentation. So if that's the case, have a good one, and thank you for stopping by. So how the web works. It's to become a better hacker, it's vital to understand the underlying functions of the World Wide Web and and what makes it work. DNS in detail. Task 1. What is a DNS? A DNS, which stands for Domain Name System, provides a simple way for us to communicate with devices on the internet without remembering complex numbers. Much like every house has a unique address for sending mail directly to it, every computer on the internet has its own unique address to communicate with it, called an IP address. An IP address looks like the following: 104.26.10.229, 4 sets of digits ranging from 0 to 255, separated by a period. When you want to visit a website, it's not exactly convenient to remember this complicated set of numbers, and that's where DNS can help. So instead of remembering 104.26.10.229, you can remember TryHackMe.com instead. And and then it goes to questions. And like I said earlier, I will not be giving out questions or doing labs. Task 2 is domain hierarchy. TLD stands for top level domain. A TLD is the most right-hand part of a domain name. So for example, the TryHackMe.com TLD is .com. There are 2 types of TLD. GTLD, which is generic top level, and CCTLD, which is country code top level domain. Historically, a GTLD was meant to tell the user the domain's purpose. For example, a .com would be for commercial purposes, .org for an organization, .edu for education, and .gov for government. And a CCTLD was used for geographical purposes. For example, .ca for sites based in Canada, and .co.uk for sites based in the United Kingdom, and so on. Due to such demand, there is an influx of new GTLDs ranging from .online, .club, .website, .biz, and so many more. For a full list of over 2,000 TLDs, click here. Second level domain. Taking TryHackMe.com as an example. The .com part is the TLD and TryHackMe is the second level domain. When registering a domain name, the second level domain is limited to 63 characters plus the TLD and can only use A through Z, 0 through 9, and hyphens, which cannot start or end with hyphens or have consecutive hyphens. Subdomain. A subdomain sits on the left-hand side of the second level domain, using a period to separate it. For example, in the name admin.tryhackme.com, the admin part is the subdomain. A subdomain name has the same creation restrictions as a second level domain, being limited to 63 characters and can only use A through Z, 0 through 9, and hyphens. You can use multiple subdomains split with periods to create longer names, such as jupiter.servers.tryhackme.com, but the length must be kept to 253 characters or less. There is no limit to the number of subdomains you can create for your domain name. Task 3 is record types. DNS record types. DNS isn't just for websites though, and multiple types of DNS record exist. we'll go over some of the most common ones that you'll likely come across. A record. These records resolve to IPv4 addresses, for example, 104.26.10.2.229. And the AAAA record. These records resolve to IPv6 addresses, for example, 2606, and I forgot what that was called. It's a much longer number and it has six digits. Not 6 digits, but 6 sections of numbers. CNAME record. These records resolve to another domain name. For example, TryHackMe's online website has the subdomain store TryHackMe.com, which returns a CNAME record shops.shopify.com. Another DNS request would then be made to shops.shopify.com to work out the IP address. MX record or MX record. These records resolve to the address of the servers that handle the email for the domain you're querying. For example, an MX record response for tryhackme.com will look something like alt1 aspmfmx.l.google.com. These records also come with a priority flag. This tells the client in which order to try the servers. This is perfect for if the main server goes down and email needs to be sent to a backup server. A text record or TXT record. TXT records are free text fields where any text-based data can be stored. TXT records have multiple uses, but some common ones can be to list servers that have the authority to send an email on behalf of the domain. This can help in the battle against spam and spoofed email. They can also be used to verify ownership of the domain name when signing up for third-party services. Task 4 is making a request. What happens when you make a DNS request? When you request a domain name, your computer first checks its local cache to see if you've previously looked up the address recently. If not, a request to your recursive DNS server will be made. 2. A recursive DNS server is usually provided by your ISP, but you can also choose your own. This server also has a local cache of recently looked up domain names. If a result is found locally, this is sent back to your computer and your request ends here. This is common for popular and heavily requested services such as Google, Facebook, and Twitter. If the request cannot be found locally, a journey begins to find the correct answer, starting with the internet's root DNS servers. The root servers Step 3 is the root servers act as the DNS backbone of the internet. Their job is to redirect you to the correct top-level domain server, depending on your request. If, for example, you request www.tryhackme.com, the root server will recognize the top-level domain of .com and refer to the correct TLD server that deals with .com addresses. 4. The TLD server holds records for where to find the authoritative server to answer the DNS request. The authoritative server is often also known as the name server for the domain. For example, the name server for tryhackme.com is kip.ns.cloudflare.com and uma.ns.cloudflare.com. You'll often find multiple name servers for a domain name to act as a backup in case one goes down. 5. An authoritative DNS server is the server that is responsible for storing the DNS records. For a particular domain and where any updates to your domain name, DNS records would be made. Depending on the record type, the DNS record is then sent back to the recursive DNS server, where a local copy will be cached for future requests and then relayed back to the original client that made the request. DNS records all come with a TTL, which is a time to live value. This value is a number represented in seconds that the response should be saved for locally until you have to look it up again. Caching saves on having to make a DNS request every time you communicate with the server. Task 5 is a practical. Oh, I will not be going through the practical. But the practical is using the website on the right, we can build requests to make DNS queries and view the results. The website will also show you the command you need to run on your computer if you wish to make the request yourself. And so that's it for the third section of pre-security. And they have their own video, as you can see, and it's a lot better. But anyways, thank you for stopping by. And if you've gone this far through the video, thank you so much, and you have a wonderful day. Goodbye.